Hello, everyone. Thank you for joining us today, and welcome to our webinar, Driving DevOps Transformation, Leveling Up CI/CD with Static Code Analysis. In this webinar, we're going to explore static code analysis and how combined with unit testing can lead to high-quality software development and delivery. I'm Tony Graham. I'll be your moderator for this webinar, and today's presenter is Peter McKee. Now, please allow me to quickly go over some essential housekeeping points before we start. This session will be 45 minutes, including a Q&A at the end. We invite you and encourage you to ask questions during at any point during the webinar, but please use the Zoom Q&A box. Please don't use the chat box. Please submit your questions in that Q&A box, and please feel free at any time during the webinar to do that. Because we do have two panelists joining us today, Dennis from our product management team and Robert from our product marketing management team, and they are tasked with answering all your questions live, excuse me, during the webinar. This session will be recorded, and we will send out an email with some, and we will send out an email with a link in it. And finally, at the end of the webinar, we're going to have a survey that will pop up on your screen. We consider your feedback a gift. We truly appreciate it, and we thank you in advance for your participation. So now, without further ado, I would like to introduce to you today our presenter, Peter McKee. Peter is the head of developer relations and community here at Sonar, and he is the maintainer of the open source project Ronin.js. He is originally from Pittsburgh, Pennsylvania, but currently resides in Austin, Texas. He has built his career developing full stack applications for over 25 years. And although he's held a multitude of roles, his passion, or he truly enjoys teaching and mentoring the most. So Peter, thank you for joining us today. And with that, I will turn it over to you. Microphone.
All right. Yeah, sorry about that.
Yeah, no.
Yeah, there we go. Yeah, rookie mistake. Hey, everybody. I had mute on. Yeah, thanks, Tony. Appreciate it. My name is Peter. Let's take a quick look at the agenda. So I'll be start off talking about what challenges there currently are to delivering software, what our current solution is to some of those challenges, what's wrong with that current solution, and then how do we fix it? And I'm going to tie in software quality, so a little look ahead. And then how to achieve quality software at scale, and then we'll kind of conclude things up. But let's go ahead and jump into it. So what are the challenges to delivering software today? So there's an ever-increasing pressure to deliver software faster, right? Developers are constantly being asked to produce more, to do better, go quicker. And software is everywhere now, right? At home, I have a refrigerator that has software. It's connected into Wi-Fi. My washing machine and dryer for my clothes are on the Wi-Fi. They talk to each other. They tell each other when they're going to complete it so they can manage time together. It's very interesting. But so software is everywhere. And so it's a huge, huge part of businesses, right? And we're being asked to produce more and go quicker. So business leaders want features delivered fast. I know I keep saying that, but it's very, very important. Features delivered fast. They don't want it to increase technical debt. They do not want to have Sev 1s and Sev 2s in production. And heaven forbid, they don't want to be hacked, right? Don't have my face show up on the nightly news. If we even watch nightly news anymore, don't have my face show up on the internet, right? Do not get hacked. And so if we kind of think about this and put it into software engineering terms, so business leaders, what they really want is they want software that's maintainable, right? So they don't want technical debt. They don't like when you say, hey, I'm going to build this feature, and then you go off and do it, and then you come back and say, well, the way we built that, now to add some features to it, we have to take 2 steps back, fix some things so we can take another step forward, right? So they want it to be maintainable. They want it to be reliable. They don't want those Sev 1s, Sev 2s that we looked at, right? And they want things to be secure, right? Don't get hacked, right? And they want all of this delivered at speed, right? Go fast, deliver now, right? How do you increase your velocity? More story points. If there's software engineers out there or software leaders, right? You hear that all the time. So what's our current solution? How do we produce software now? But before we kind of look at that, let's take a step back and look at how we got to where we're at. And before the Agile movement, we did waterfall, SDLC, so software development lifecycle. And this model followed a waterfall, right? You did one phase, completed it, did the next phase, completed it. So he went and gathered requirements, did analysis, then did system design, then implementation, integration, deployment, and maintenance, right? And each one of these phases could be a month long. They could be 3 months long. A full project could take a year long. I was working at a large manufacturer of computers here in Central Texas, and we would do waterfall, and we would do a year-long project, right? But if you ever bid on one of these projects, or ever built a house, right, a custom home, it's kind of the same thing. You go and look at a model home, you say, yep, that's the one I like. So you gather requirements and you do some analysis, right? You system design, you sit down with an architect and you look at the floor plans and you design your home based on that model home. You go and implement it, and then you integrate. You show up at the house to do a walkthrough, and what happens, right? You say, this isn't exactly what I was thinking in my mind. I wanted this kitchen sink maybe moved a little bit, or I want it on this wall and not that wall. And then the general contractor steps back, like just like a software engineer, and says, well, it on the surface it looks easy, but underneath I have all this plumbing. I have wiring, I have plumbing, I have foundational things. It's not just that easy to move a wall or to move a sink. Same thing in software. And so we started looking at how's a better way to do this. And along came the agile movement. Now, before we move on, I'm going to say the next things with love, and I don't mean to offend anybody, but if you say you do agile, right, or we're an agile shop, you are not. Agile is not an SDLC. It is not a software development lifecycle, right? Agile is a set of principles behind the Agile Manifesto. So some folks in the industry got together. They sat down and said, how do we produce software better? And they wrote this manifesto. And you can go read it online. It's the agilemanifesto.org. It's a set of principles, right, that drive an SDLC. And so while I don't agree with all of them, there's some really good things in there that came out of it and kind of lead us to where we're at now. So if you start, just a couple bullet points here. So highest priority to satisfy the customer through early and continuous delivery of software. Deliver working software frequently, continuous attention to technical excellence and refinement, right? So you're seeing these continuous deliver software quicker, get it to the customer quicker, get to functioning software faster, right? And let's iterate. And so that kind of led us into continuous integration. So we automated our builds and our tests, and we ran unit tests and integration tests. And then we said, well, this is great. Let's do continuous delivery. Let's continuously integrate, build and run our tests. That works. And let's continuously deliver into production, right? So we automated our deployments. We built reliable release processes so we can release more frequently, and we can get to production ready code quicker, right? And so what's wrong with this? This sounds great, right? We moved a lot of bottlenecks. We went from this full waterfall solution to a more iterative, agile solution, right? And but there's some problems, right? Unit testing is only focused on functionality testing. So if you look back at your CI/CD processes, continuous integration, the key to continuous integration is you have to automate your tests, right? Before we had a big QA team standalone, we'd write code, we'd throw it over the wall, they test it, they throw it back, right? And we kind of shifted left with that. And so we really focused on unit tests and integration tests. Well, unit tests only test functionality, right? They do not test for code quality. And so if you think about the difference between code quality and functionality, I'll give you a real world example, and I'll go back to the house again. Excuse my my weird analogies, but in a house, right? Let's say we built a door, and if we functionality test that, right, we can open the door, we can close the door. It swings nice on the hinges, it opens and closes. Great, functions, check, you pass, right? 2 days later, you open that door and it falls down, right? We didn't quality test it. We didn't look at the quality of the screws, the quality of the nails. Did we use the right attachments? Was the weight correct for the door? Was it too heavy, right? We totally skipped quality. We only looked at functionality, right? And you say, well, a lot of you out there might be scratching your heads, but I guarantee you, if you look back in your past, if you wrote enough code, you have written really bad code, but it works, right? Really hard to maintain. You come back a couple weeks later and you look, oh, who wrote this code, right? Oh, great, it was me, right? And then couple on top of that, unit testing is hard to commit to, right? There's always a debate. How much code coverage do we do? Do we get to 90%, 80%? You're going to end up writing at least 50% more code, up to 50, 60, 70% more code. If you look at the literature in computer science around unit testing and automating testing, these type of things, you start to get a diminishing of returns around 60% code coverage. TDD is doing a lot more and it is raising that a little bit, but really take a look at, am I getting enough ROI out of my unit testing, or are there other things I could do? So main point here is unit testing only focuses on functionality and not quality. And so here it is right here. Functioning software does not equal quality software. So we have functioning software, great. So we're delivering high value functions into our business, which was one of the things that they're looking for, right? But is it maintainable? Is it reliable? And is it secure, right? That's where you start looking at software quality. So what is software quality? So Justice Porter Stewart was a Supreme Court justice back in 1964. They were working on a case around obscene content, and some reporters asked him, how do you define obscene content? And he said, well, a bunch of things before this, but he said, perhaps I could never succeed in intelligibly doing so, but I know it when I see it, right? And I think as software engineers, this is how this software quality works, right? We don't necessarily know how to define it, how to clearly state it to you what quality software is, but we know it when we see it, right? We know when we look at code bases that are structured well or written well. We know it when we see it. Well, at Sonar, we decided to fix that, right, and dive a little deep into it. And so we started thinking about quality software. We decided to call it clean code. Your code is clean, or you're cleaning your code. And we started looking at software qualities, and we kind of talked about these, right? Security, maintainability, reliability, and others, right? What are the qualities of software that we want? And then we started looking at what are the code attributes that then produce those qualities, right? What are our patterns in code that produce these qualities? And we found 4 major buckets, right? So consistent, intentional, adaptable, and responsible. And I'm not going to dig into all these. I'm going to give you one example in a minute, but these attributes cross all programming languages. So functioning programming languages to object-oriented languages, your scripts, all of the code fit into these attributes. So if you strive to write code working with these principles around these attributes, you will produce clean code. And so this is what this slide is saying here. Focus on your clean attributes. These lead to software qualities of maintainability, reliable, and secure code. And so just jumping in and giving an example, this is one of my favorites. And so this is around modularity. I like to call it cohesion and coupling. Those are not my terms. Those are computer science terms that have been used for a while. But if you look to the examples on the right, you see a non-compliant code. So class foo, public bar equals 42, end class, right? And so we have a public property there. And what's going to happen, right? Software engineers are going to start using bar all kinds of different ways that the creator of the class foo didn't expect. And so now you have leaky abstractions, right? You have tight coupling, tight binding to these classes. Where in your compliant code, you see a public property. So it's using the programming language constructs to create modularity, encapsulation. So now you have a property that then you can control the way that property is set and retrieved. And so these are cohesion and coupling. You want things that are highly cohesive with low coupling. So if I can give you a real world example around cohesion and coupling, I'm not going to go to the house, but I'll go to another common thing that everybody should know is around cars and car batteries. So if you think of a car battery, it has cells in it that can store energy, and then it knows how to expel energy. That's it. It doesn't know anything else, right? It doesn't know about a car. It doesn't know about a plane. It knows how to store energy and expel energy, right? And that's a battery. And that's highly cohesive. It does one thing and does it well, and it's all put together, right? And then it's loosely coupled. It has 2 prongs on the top, a positive and a negative. That is its interface, right? And so when you connect the cables, you get power, you can start your car. You can unconnect those cables, pick up the battery, go put it into your boat, reconnect the cables, and start your boat, right? So it's loosely coupled, 2 little connections, right? Highly cohesive, loosely coupled. So this is an example. I wanted to go through this one and some of these attributes. So it's not just format your code correctly, use consistent semicolons. Those things are all very important, right? But it goes deeper than that, right? How do you construct your code? How do you use modularity to write good, clean code? Good. So clean code produces quality software, right? That's the point here. So if you focus on these code attributes that are common across all our software languages, if you write code in those practices, that you'll achieve clean code. And so how do we do this at scale? So this is where static code analysis comes in. So what is static code analysis? So static code analysis is a method used in software development to evaluate the quality, correctness of your source code without executing your program. So basically what we do is we take your code, we parse it and turn it into an abstract syntax tree, and then we run rules against that, right? And we're looking for things like code issues, errors, quality smells, um, bugs. So errors in your code. We're also looking for vulnerabilities, points in your code that have a security attack surface. Um, and then we're looking for code smells. This is around maintainability. If you have a function that has 1,000 lines in it, right, that obviously that's a code smell and you should probably refactor that. So these different types of things. We also look at taint analysis. So what taint analysis is, it looks at the data coming into your application, and then it follows those variables, that data as it runs through your functioning stack, your function stack, and how it's being called across your application. And it watches it to see if it's been changed, been modified. If it's been changed or modified, where did that new data come from? Has that data been cleaned first and then attached to that data that we're watching? If not, then it has become tainted. So while you might bring data into your API endpoint and you might check the data there, but then you pass that data to another function, pass it to another function. And let's say you read some data off a disk and you don't clean it. And now you concatenate, create a SQL statement, and you call your database, right? You've just tainted your data, you possibly introduced security risks, all those type of things, right? And so we do that. We follow your code throughout. We also do some security testing around SAST. We look for security vulnerabilities. We also do deeper SAST, we call it. So we'll not only look at your code for security vulnerabilities, we also pull in third-party open source modules and we scan those, right? And we cache them, so we don't do it all the time. But we're also looking into third-party open source modules, right? So we can scan the code at the code level, which is a little bit different than just looking up vulnerabilities and see if they're in the versions that you have. We're actually scanning the code. And so there's a big other side to this of why this is important, right? Of why quality software is important and why you should strive to write code, right? Engineers are a big part of software development right now. I know generative AI is very hot right now, but it's not going to replace engineers for any foreseeable future, right? We will always still be writing code, and maybe it changes at the abstract levels and how much code you write, but we're still always writing code. But generative AI just exasperates this problem even more, right? So engineers are being burnout's a big, big issue, right? And most of that burnout is coming from fixing code, debugging code, working on code that's not structured well, that has issues in it. It's not clean. It's not written well, right? And engineers are frustrated with this, right? What we want to do as engineers is we want to fix problems, write code to fix problems and bring value, right? So Fabrice, my boss, actually wrote this report. So 44% of developers claim that addressing software flaws and issues is the most frustrating, right? This is causing them burnout. A study by Haystack found that 83% of software developers suffer from burnout, right? So not only getting your code to high standards, good quality, produces good, reliable, maintainable, secure software, but it also helps your engineers to be happier and be more productive, right? They're able to focus on the problems that they were hired to do and move the business forward by delivering good quality software. Okay, great. So how do we power up our CI/CD? How do we take these things that we've talked about and how do we start implementing them? So again, I want to jump back and really nail this point home that unit testing is not enough. Please unit test your software. Testing's important. If you ever see me out in the wild, and maybe we can have a beer together and we can debate how much unit testing and how important it is. But it's very, very hard to argue against testing, right? Absolutely, test your software, but it only focuses on functionality, right? That's only one side of the coin. We're missing a huge other side to the coin, and that's where static analysis comes in, and that focuses on quality, right? And that broad definition of quality. So clean code produces quality software. You need both, right? You need both. So clean code is the precursor to quality software. You need to have clean code written with those clean code attributes that will produce quality software. Code that's consistent, intentional, adaptable, and responsible. And if you want to learn more about those, you can go up to our website, dig more into them. You can reach out to me, ask me questions about it. I'd love to talk about it more. So consistent, intentional, adaptable, and responsible. And that produces code that's reliable, maintainable, and secure, right? And this is what our business wants. And so how do we do that? So we have a couple tools, open source tools that you can try out and plug in. So this is the classic figure eight of the development lifecycle. If you look at the top left in the coding section there, in the middle of that eight, we have Sonar Lint, which is our IDE plugin. It's way more than just a linter. We do linting, but we do way more than that. We support all the major browsers. So if you go into any one of your browsers, anywhere you could do a plugin, go install it. It's free, open source. And that will help, that's Grammarly for software engineers, right? So as you're writing code, it's going to help you write better code and show you your issues in real time. And so you write some code, you commit it, you push up into the cloud, and this is where your CI/CD starts kicking off, right? Your CI kicks off. Before you unit test, you should static analyze your code. To me, quality is before functionality, right? Functionality is great. You need it to be, yeah, that's table stakes. It needs to work, right? But you need quality software, right? To maintain, to eliminate all these things we've been talking about. Quality is where it starts. So to do that, download Sonar Cube, free open source. You can install it, run it locally, or use Sonar Cloud if you're more geared towards the cloud. We have a free offering. If you have an open source project, it's free. If you have private repos, we do a trial. So sign up for the trial. Start standing your code. So we wrote some code, we checked it with lint, we pushed it up, we kicked off our CI, we started scanning our code. So a quality gate then comes in and checks the quality of your code. If it passes, great. Continue your unit testing, integration testing, whatever you do, and go into production. If it fails, kick that back to the engineer. Now there's a great feature in Sonar Lint called connected mode. So as the engineer is working, you should connect Sonar Lint into Sonar Cloud or Sonar Cube. And what that does is it allows the rule set that you've made on Sonar Cube or Cloud be synced up with Sonar Lint, right? So if you have a rule on Sonar Cube that you've changed the severity to or whatever, or you've taken out as a rule, sync that up with your IDE, and you'll see that as your code. Also, a lot of these advanced features around taint analysis and DBD and security issues, we only do that on the server. The reason being is in the IDE, we don't want to bog down your machine, and scan your whole repo. With Sonar Lint, we only look at your open files, right? So it's very important to connect that into connected mode, right? So again, you're writing code, you're looking at it as Sonar Lint, it looks good, you push it up, you kick off your CI, you run your static analysis, make sure you have clean code. If it passes the quality gate, go to production. If not, reiterate, right? And put into connected mode. But what happens, right? What happens? You turn on static analysis, you're going to get a bunch of issues. You're going to get thousands of issues, right? And as a good development team, a good lead, a good principal engineer, you turn it off. No, don't turn it off. There's a way to attack this, right? So the way to attack a multitude of issues is a development process we call clean as you code, right? So you're moving towards clean code, so you're going to clean it as you code. And the way you do that is you focus on your new code that's been added or modified. And if you do that, if you only focus on cleaning the code that you're currently writing or that you're modifying, refactoring as you're writing the new code, then things get done as you're coding, right? It's non-disruptive. There's no rework. It allows the developers to work the way they work best, right? Focusing on new code and modified code. They're cleaning, they're using those attributes, they're writing good code. And then there's two steps in our product. You go and set up a quality profile. Quality profile is a set of rules that you want to test when you scan. And then a quality gate says, this is the level of quality that the code must reach to go to production. So you set gates. So no high Sev 1, Sev 2 security issues. That'll fail the quality gate. No high Sev 1, Sev 2 maintainability issues. That'll fail the quality gate, right? So you set up those two things. Get your profile. We have a very good standard profile that you could use and you could modify. And then set your quality gate. And then everything runs through your quality gate. Only the code that you're changing, right? Refactoring or adding, right? And do not release unless it goes green, right? Get bullish on that, right? Really think about quality, right? It will play the long game, right? I know the business wants to go fast. They want to deliver quality. They want all the things we've talked about. Play the long game. Really focus on quality and your life will be much, much better. So how long does this take, right? Okay, I got thousands of issues. I believe in clean code. I'm focusing on quality. I know that it's going to speed up my CI/CD process. It's going to allow my engineers to focus on what they do best, writing code. It's going to give me a level of confidence that my code is maintainable and reliable and secure. But how long is it going to take, right? This is an old code base, and I'm feeling like I just need to put someone over on the side just to work on it. Don't do that, okay? So we kind of looked at our own code bases. So we looked at Sonar. No, first of all, this is Get a Thesis on GitHub. So we took a look at a bunch of open source projects, and basically we were looking at the half-life of code. How long does code stay in a repo? And you can see on this graph that it goes down. The code life expectancy is about 3.33 years. So 3.33 years is as long as your code bases last. And so we started running that against Sonar Cube and to see, how does our code stack up? This was in about 2018. We had about 1 million lines of code. And over about 5 years, you can see we got down to about 60% code coverage in about, 4 or 5 years. And so what we did was only focus on new code that we produced and the code that we were refactoring. And over 5 years, we've gotten to huge major coverage of our code base and cleaned it. And so this is what it kind of looks like. So starting out today, nothing's been cleaned. After 1 year, you get about 20%, doing pretty well. After 2 years, you get about 35%. And then 5 years, you're 50% or more. I've seen more, right? So the question I always get asked is, yeah, Peter, but what about that other 40% that I haven't touched over the last 5 years? What do I do with it? Nothing. Let it be, right? It's reliable. It might not be maintainable, and it's secure, right? If it wasn't reliable or secure, you would have had issues popped up, and over the 5 years, you would have fixed it. You would have cleaned it, right? So it's reliable and secure, but it might not be maintainable. But you haven't touched the code in 5 years. So why focus on it, right? You're not going to get a return on investment putting that energy in. So just let it go. Focus on new code and refactored code, and you get down to 60% coverage after 5 years. Okay, awesome. Covered a lot. Appreciate your time. Here's some resources. So go download Sonar Cube, the community edition. It's free, open source. If you know Docker, you can go download two containers. Run one is the UI, the actual application. The other is the scanner. Make sure you put them on the same network so they can talk to each other. Yeah, rookie mistake. I did that. Pulled my hair out for about 45 minutes. Couldn't get them to talk. Yeah, they need to be on the same network, but pretty straightforward. Again, if you have questions, reach out to us. Jump into our forum. We have an incredible forum. Ask your questions in there. We have great community managers, our engineers in there. We'll get you unstuck. We'll get you moving forward. And then install Sonar Lint in your ID. Again, free, open source. Use it, right? You might say, well, I already have an ID. I already have a linter, right? I'm already using a linter. Fine. Use ours beside it. We do more than linting, right? And the reason being is connect your Sonar Lint into your Sonar Cube. That's where the huge, huge value comes. So you're going to get massive value out of Sonar Lint by itself. There's some learn as you code stuff in there that I haven't even touched on, right? But when you connect it into your Sonar Cube, that's where the real magic happens, right? So connect it into Sonar Cube, Sonar Cloud. And then start scanning. And then start focusing on your new code and refactored code, right? And start seeing what issues you have. See how you can improve your code bases, right? See where the issues are. All right. Thank you very much. Let me kick it back over to Tony.
Thank you, Peter. That was really great. Appreciate that. So again, before we get into Q&A, now that Peter's gone through all that, gave us a lot of information there, throw your questions in that Q&A box, and we will get to those here in a second. But before we do that, I want to share share two upcoming webinars on Tuesday, April 23rd and Thursday, April 25th. These are given by Manish Kapoor, and they are how to use Sonar with the AI coding assistance to write faster and to write cleaner code. So there should be a link coming up for those here in a second, so you can register for those. And then, there's a reminder that there's a short survey will appear. We greatly appreciate your feedback. So if you could fill that out, we'd be super happy about that as well. Okay, so it looks like we do have some questions. Peter, if you're ready for some questions.
Yeah,
So
shoot.
we have a couple of great ones here. Like I say, encourage everybody, throw those questions in the Q&A now. We do have, a couple minutes for these, so we can knock some of these out. So here we go. What is the role of DevOps towards software quality? Should it be DevOps who pushes dev teams for software quality, or should it be dev teams pushing the dev teams pushing DevOps?
Yeah, great question. I'm gonna steal that question. I'm gonna use that as
Yeah, it's a good one, isn't it?
softball question. Yeah, that's a fantastic question. Thanks for asking that. Yeah. We debated this a little internally, and I've had discussions with engineers and out in the wild too in the communities. If you kind of think about unit testing, right? So unit testing came along through software engineering, right? And kind of trying to improve that process, right? And so testing is laid upon the engineer, right? Write your unit tests, make sure you test your code, right? Make sure it passes, those type of things. But then I think it's a shared responsibility between DevOps, right? No DevOps engineer worth their, weight in gold or whatever the saying is, right? Would implement a CI process without unit testing, right? You would reject that, right? You would go back to the engineering teams and say, hey, look, you need to test your code. It's not passing, right? Rarely, though, the DevOps engineer is not responsible for fixing the code. They're not responsible for the unit tests themselves. They're responsible for running them and then setting up the systems. If they pass, go. If they fail. I think it's the same thing here, right? It's a shared responsibility, right? I think as a DevOps engineer, now that you know about static analysis and software quality, right? I think you should advocate back into your engineering teams that they do this, that they look at this, right? But then I think it's your job to make sure once collectively you agree we're going to start doing this, that needs to be implemented in your pipelines, right? And you're the gatekeeper to that, right? If the quality gate is not passed, right, you do not let that CI process go, right? So you're kind of the quality gate, but again, kind of like unit testing, you're not responsible for the quality, right? So that's when you still go back to the engineer and say, look, you failed your quality, you need to go fix it, right? So I believe it's a shared responsibility. So I think it's a mindset with the organization to understand these things and then work together on how you implement. Yeah, great question. Thank you.
Yeah, absolutely. That was a good one. Thank you, whoever asked that one. So another one now. So you touched on the clean as you code, and you're only touching right your new code or code you're modifying. But so what is the recommendation on how to implement it? Do you have to fix anything major first, or can you just dive in right with the right with your new code that you're writing?
Yeah, I would definitely focus on the clean as you code, right? I see a lot of, and this is difficult, right? I know this is difficult, right? So you really have to stand firm with your leaders, your technical leaders, right? And really convince them that no, putting a junior engineer to go and just focus on these 1,000 issues that Sonar Cube has shown you and fix them is not healthy, right? Is not a good way to do it. First of all, because it's around code quality, right? And what happens is you end up putting a junior engineer on it or a mid-level engineer. No offense to any juniors and mid-levels. We all have gone through it, right? You don't have, you might have the knowledge, but you don't have the wisdom, right? You need the wisdom to really clean up these code bases, right? They're old, they're brittle. It takes a lot of cognitive power and industry experience to really know what to change, when to change it, and how to change it, right? So I think it's a really bad idea to slice off some time and resources to only focus on these issues as you move forward, right? Especially with the evidence that presented today with get a thesis and kind of our own code bases. And we're seeing this with our clients, right? If they focus on new code and refactored code, that over time, you clean your whole code bases, right? And the issues will come up that you need to address when you need to address them, right? So yes, in your workflows, your SDLC, right? You're reviewing, you're looking at high severity issues, you're looking at maintainability issues, right? And then that's a discussion you have on priorities, right? We need to build features, but we also have these issues that we need to attack, right? And so you look for that correlation. So start working on the issues that are close enough to your feature that you can work together to fix them, right? And start working through your code base that way, right? Um, yeah, so it's a classic problem that I see amassed about a lot, right? The anxiety bubbles up a lot when you say, "Yep,
I
don't go
bet.
over there and work on all those issues. Let's just focus on new code." And that sounds all great and dandy, and it is. It really is, right? So I would focus on that because what happens, right? Because you've been ignoring these things for a while. They've been there forever, right? And if you would have been following these practices, let's say 6 months, I mean 6 weeks, have you been discussing should we focus on these, right? You would have hit a bunch of them anyway. So
Good point.
focus on what you do best. Focus on new code. Yeah.
Awesome. Thank you. So what are the requirements for Sonar Lint? Does it need JDK or other installs?
Yeah, no, it's all packaged up itself. I think we might have removed the JDK requirements. I can't remember, but it'll be seamless to you, right? So in the IDE, when any VS Code, right, in the extensions you installed it, it'll run. Um, it should be painless. Again, if you have any issues, right, if you have some edge case on some version of an IDE that might be a little um, funky, reach out to us, reach out to the forum. We'll get you squared away, but it should be seamless. Yeah.
Okay, here's another really good one. So how much should we focus on code smells while explaining issues to developers? I'm a security engineer. Day-to-day activity is to work with developers to explain bugs, vulnerabilities, and ask them to fix. But it's hard to explain code smells when they are in the hundreds.
Yeah. So I assume the importance of code smells is probably, yeah. Yes. Okay. So yeah, the other issues are more concrete, right? Like if you have a bug, hey, you got to fix it. It's easy to show this is an issue. You need to fix it, right? Same with the security vulnerability. Hey, it's right here. It's a CVE. You're using this pattern. You need to fix it, right? Yes, code smells are a little bit different. So we have I have some resources we want to reach out. I can send to you, but working on code smells again is the foundation, I think, for quality software, right? And so really focusing on that cohesion and coupling is really around a lot of your code smells, right? A lot of larger functions, just the patterns and practices that you're using are bad patterns, right? Their code smells are bad, right? Which are going to lead to long-term issues, right? Reliability and maintainability, right? So I think you really have to focus on that issue. Um, and we're playing around and working a little bit of looking at ROI on these type of things and how do you really measure the quality of your software over a long period of time and how does that affect your software development life cycles, right? But yes, it's an issue, right? I think you have to attack it with education, right? And have to advocate that these things, while they might not be, high priority, a thorn in our side, right? They are going to lead to that, right? It's like you're bleeding, right? Slowly. And eventually you're going to fall down and die, right? And then, sorry, not to get, a little dark on you, but right, it's a slow drain and it adds up, right? Where you might see, there's arrows flying at you and you're fighting those while you're slowly bleeding out, right? So um, focus on those two. You have to hit the major ones, the bugs and security issues. But for me, playing the long game again is code smells, code quality, your modularity, those type of things really need to be focused on. I would suggest get to partner up with your staff and your principal engineers, right? And those are the ones that have the clout that can influence the engineering teams. Yeah.
Thank you.
Hmm?
So does Sonar Cloud scan all third-party modules inside the repo or only those third-party modules which is called in the project? Is it configurable?
Oh, great question. And you know what? I'm not sure if I know that answer. I think it follows it with on code paths, but to be honest with you, I'm not 100% sure on that answer. So let me we'll make a note and I'll answer that and we'll post that in the forum. Yeah, I'm not sure. So if you have modules included right in your package manager or whatever, do we scan all of them or do we only scan the ones that are being used, right? which then leads to a nice feature that you can say, hey, you have these modules included, but you're never using them anyways. But
Yeah, nice.
yeah, I don't want to answer it and I don't want to take an educated guess on it. So let me get the exact answer. Yeah.
Okay. And then, uh, so how does this product differ from GitHub or Git Advanced Security? When I select this, what's the benefit compared to GitHub Advanced Security?
Uh, I'm going to dodge that question.
Okay.
Yeah. Yeah, I think that's a longer discussion, right? And like all those could, it depends, right? It depends. Depends on what you're looking for. It depends on what you're evaluating. It depends on what your goals are, right? The feature sets are similar but different, right? So I think that's a conversation that we could have probably offline, and it won't. Yeah, too general will be too general, and it would need to more specifics. Yeah, my apologies about that.
No, absolutely.
Yeah.
So what's the granularity of clean as you code? If I just modify one line of existing code, will the entire class go through the quality gate?
Yes. Yeah. It'll go for it. It'll go through a file. It'll be scanned. Yeah. We look at deltas, but we scan the whole thing. Yeah.
Okay.
We actually scan your whole code base, but only look at the deltas. Yeah.
And then, so here's a couple. So do you have, well, you're talking about the hosted solution, which is Sonar Cloud,
Mm.
right? So how do you choose between the two, like between Sonar Cloud, Sonar Cube?
Yeah. Great question. I would default to cloud, right? Go to Sonar Cloud. You don't need to host it. You don't need to maintain it. You don't need to make sure it's scaling, right? Like all of those features you already get baked in, right? Because it's in the cloud and we handle all that. With Cube, um, you have to install it, maintain it, and run it yourself. So I think the number one thing first looking at is, do I need an on-prem solution? If I need an on-prem solution, look at Cube. If I don't need an on-prem solution, right? If I don't need to be air gapped, if I don't have data issues or whatever, then go to the cloud, right? It's just easier. It's a SaaS, right? So you get all those benefits. Um, those are the main two things. The feature sets are pretty comparable, pretty rich. There's some features in Sonar Cube, like extensions and things like that. So if you have some very customized workflow plugins and those type of things, then Cube might be better as opposed to cloud. Again, these questions, really depend on, it depends, right, on some of your goals. But generally speaking, if at all possible, I would go with cloud. It's just easier. You don't have to do all the maintaining things. It's easier to get up and running and scanning very quickly. Where with Cube, you have to install it, maintain it, and run it. If you're looking at a POC, you could do both, right? If you can download Sonar Cube, run it locally, scan, you can get a good idea of what you're doing, test it out. But those are the main things I would look at. If you need extreme high availability in your data center, we have a product for that too. So there's across regions and stuff like that. So it gets pretty complex into architectural design decisions as you get bigger. Between the two, but generally speaking, if you're in the cloud, more in the cloud, go with cloud. If not on-prem, I would look at Cube.
Okay. And that, excuse me, can devs install Sonar Cube on their laptops and run it against their local code repository?
Yes. Yeah. Yep. Yep. Easiest way to do this with some Docker images.
Okay. And then we're right at 45 minutes, but so I got one here that's so sold, but I'm worried management will not be, right? How do I convince management? Like, and then yeah, so how do I convince management? I think that's
Yeah.
good question to end with.
Yeah. So I would say definitely get your development teams using it, right? Get it running local cube or running cloud, get the team involved, get them seeing the benefits, right? See how it improves the quality of your software, right? Coupled with your unit testing, right? Actually do a little POC, get the team on board, right? So now you have good influence up the stack, right? Management will always listen to tools that help you go faster and write more maintainable, reliable code, right? So I would get to know the product, understand the benefits, and then take it to management and say, hey, look, we've been doing a POC. We've been using this the past month. It's extremely helpful. It's helped cut down time on our code reviews. It's cut down time on refactoring. It's cut down time on explaining code and understanding our code bases because we're standardizing things, right? All these things as a staff or a principal or a team lead that you're looking for, right? Sonar can help with, right? And so bundle all that information and then go beat up your manager with it. But right, and sell it up the chain, right, as an essential tool. And to be honest with you, most engineering leaders, right, and business leaders understand, right, if you're asking for, you're building houses. Here's a house analogy again. Sorry, you're building houses with a hammer and nails, right? And your carpenter says, "Hey, there's these new nail guns. I can go 10 times faster. Should I get it?" Yes, right. Like it's kind of that. So once you start showing the benefits and your team is convinced, then it becomes a lot easier to convince and influence up the chain, right?
Oh,
And sorry, just one key thing there, right? Understand the language that your technology leaders speak and your business leaders speak, right? They don't talk about code smells, right? They're not interested in, they're interested in vulnerabilities, but they don't understand what those are. They don't understand what code smells are. They don't understand what consistent formatting and consistent use of third-party library, like what that means to them, right? So you have to talk about reliability, maintainability, and secure, right? So talk about how you can go faster while producing better code that's easier to maintain, right? Cutting down on your technical debt, right? If you talk about that level and the business benefits they get, then they'll understand, right?
that's great advice. Speak their
Yeah.
language.
Speak their language. Yeah.
Yeah. All right. Well, thank you very much, Peter.
Very
And
welcome.
sorry for those. I think there might have been a few questions we didn't get to. We will address those, you know, uh, afterwards. So I do appreciate everybody for stopping by, for staying. Peter, again, thank you so much, and have a great day.
Awesome. Thanks, everybody. Appreciate it.